states that also have their DOTs under a general permit. Virginia is not alone in that. The Virginia DOT has been informed by the Virginia DEQ that likely by the end of this year they will be moved to an individual permit. So that is something else that, in addition to the changes that I'm going to talk about in this presentation, the known changes that the DOT is facing, there are also future unknown changes likely later this year that they will also be facing. So stormwater pollution prevention, and that's really what a lot of this is all about. As I said, there are rules that govern construction projects, and in Virginia there's a construction general permit, and all of the VDOT projects, most of them, any of them that are over an acre, are subject to getting this permit. This permit requires that each of these sites have a stormwater pollution prevention plan, or SWIP, and there are several parts to the SWIP. One, I think, was referenced earlier today in another presentation, the erosion and sediment control plan that needs to be in place for during construction, trying to minimize the non-stormwater discharges that leave a construction site during construction. There's also the pollution prevention plan that needs to be part of that, so that all of hazardous or any other potential harmful constituents at a site, such as paint or gas or oil, are controlled on site and handled appropriately, so that if there's a storm event, they don't commingle with the stormwater and leave the site. And then there's also post-construction in Virginia. Not all states have post-construction stormwater requirements, but Virginia does. And I'm going to talk a little bit later about how those are actually the new, what we typically call the new Virginia stormwater management regulations that went into effect last year in July of 2014. And then there's also, as I was saying, the MS4 permit. Both of this, the construction general permit and the MS4 permit, are Federal Clean Water Act discharge permits, but they are administered in Virginia by the Virginia DEQ. And I said also earlier that that VDOT is subject to the small Phase 2 general permit in Virginia, and as part of that, there are 6 specific minimum control measures that VDOT needs to maintain throughout their system. And for each of those minimum control measures, there are measurable goals that need to be met as part of the permit requirements. So the 6 minimum control measures as part of a small MS4, and this is not just specific to Virginia, it's for any small MS4 across the United States. There's MCM1, Minimum Control Measure 1, which is public education and outreach on stormwater impacts. There's the second one, MCM2, public involvement and participation. MCM3 is illicit discharge detection and elimination, and this has actually been one of the more talked about and controversial, if it potentially issues here in Virginia with the new MS4 permits, in that stormwater systems are not as cut and dry as often sewer systems can be, because they can commingle. So, for example, here where we are in Arlington, there can be stormwater that leaves the site that goes to VDOT, that goes to Fairfax, that comes back to VDOT, that goes back to Arlington, and you know, who's responsible for what, and drawing the line on that, and dealing with illicit discharges, which could come from a variety of sources. For VDOT, a lot of the ones that we find are people who may not be restaurants that may not be cleaning out their grease traps appropriately, and so then VDOT will then work with the locality in which that restaurant is located to have that facility cleaned up and to eliminate that discharge. But that's also a kind of a hairy subject, and something that's still evolving as to how to best handle those issues in Virginia and also in other states. MCM4 is the construction site stormwater runoff control, that erosion and sediment control measures, the silt fences and the like that are present at construction sites to keep sediment and other pollutants on site. And then MCM5 is that post-construction stormwater management in new development and for redevelopment. And then MCM6, which is also a very important one when we're talking about sustainable practices, which is pollution prevention and good housekeeping for municipal operations. So for VDOT, this could be salt storage facilities. It could also be vehicle and fleet management facilities, and there are a number of different good housekeeping practices and pollution prevention practices as part of the permit that VDOT implements as part of their MS4. And in fact, for this particular MCM, VDOT implements this statewide. They've chosen to do that as a programmatic choice, not just within the MS4 regulated area. So specific to Virginia and the new permit that came out in 2013, the new general permit that VDOT is currently subject to, for NCM 1 and 2, the public engagement, outreach, education, so working with the constituents, the drivers that use the roads, and the VDOT employees that are working at the facilities. Identify 3 high priority water quality issues and really target those with some education and outreach, and then also find 4 local activities to participate in to engage with the community. System inventory and asset management, that's NCM 3, the illicit discharge, outfall mapping and screening, and I'm going to talk a little bit about that a bit more, and the importance of that is related to that interconnectivity of MS4s a little bit later. And then I've kind of lumped a bunch of them together under pollution prevention here, which is NCM 4, really practicing good pollution prevention, good housekeeping practices during construction and after construction, NCM 5, as well as the NCM 6 that I spoke about before, good housekeeping at the facilities. And specific to Virginia and the new permit, each of these permittees, including VDOT, is to determine all of their high-risk facilities and develop stormwater pollution prevention plans that will be in place for that facility during when it's in operation for the entire length of the permit. And then TMDLs, which I'd mentioned briefly before, those total maximum daily loads, and those are really a really big issue here in Virginia and the rest of the Mid-Atlantic with the Chesapeake Bay TMDL. And I'm going to talk more specifically about that. So right here I have a map of the Chesapeake Bay, a small little sliver of water next to the Atlantic. And then if you see the white outlet, Chesapeake Bay watershed. If you notice, the Chesapeake Bay is an estuary that's very shallow, but all of that land drains into it. So all the activities that happen on that land, all of the land use choices that are made directly impact the Chesapeake Bay. So that's why we have the Chesapeake Bay TMDL right now, basically because the land use choices that we have made historically have impacted the Chesapeake Bay. And so we now have this reduction in place that all the sectors, not just the urban sector, are now required to make. It's pollutant specific, like all TMDLs, and so it's for the Chesapeake Bay, the concern is with phosphorus, nitrogen, and sediment. And to meet this total maximum daily load, best management practices across all the sectors are required. Specifically for VDOT in their MS4 permit, there's now a Chesapeake Bay TMDL requirement with specific deadlines that need to be met to meet the reductions. In Virginia, they've chosen to have a phased-in approach. So for the first 5 years of the current permit, each of the MS4s, including VDOT, will need to make a 5% reduction. And then Virginia has pledged that in preceding years, they will ratchet up that reduction to 40% and then 100% by 2025. Coincidentally, 2025 is the year in the lawsuit upon which EPA is supposed to have met, and the states are supposed to have met the total reductions under the TMDL. So the state regulation changes, these apply to post-construction controls. So after a construction site is finished, these are the controls that need to remain in place to continue to treat the runoff from the development. The water quality criteria and methodology have changed, and we've moved from the simple method, which is often used across the United States as an approach for water quality controls, to the runoff reduction method, and I have a couple of slides on that later. But in general, the new criteria are seeking to promote sustainable design, environmental site design, and conserving natural spaces that are already existing on a site, and also implementing low-impact development BMPs that come back in and reduce the amount of runoff by encouraging infiltration and biotreatment. We also have new water quantity criteria that I mentioned earlier with the energy balance equation, and I have a slide that I'm going to show later with a graph to illustrate that. And then we have BMPs, these best management practices that have been approved by Virginia DEQ to meet these regulations, and they have a whole website, the Virginia Clearinghouse, that has the standards and specifications that can be used for that. VDOT has actually undertaken a pretty big process to take those BMPs and to convert those to VDOT specific BMPs that can be used that are more applicable to linear projects. That has been ongoing and is almost finished, and it will be reviewed by DEQ and hopefully approved and then applied to and available for VDOT projects to more effectively meet these regulations on linear projects. So I said before the simple method, and I'm just going to go over this briefly. The simple method really didn't take into account infiltration and volume reduction. It really just looked at mass load reduction. So for this example, if you had a given liters of stormwater with 100 milligrams per liter of the pollutant, and you put it through your best management practice, and at the end you reduced not the volume, or maybe you did, but you reduced the concentration to 50 milligrams per liter, you would only, even if you did have a volume reduction, you would only get credit for that 50% reduction in the concentration. But moving to the runoff reduction method, we're now giving credit in Virginia for the reduction, if you can, in volume. And so this will encourage those infiltration practices and green practices for post-construction stormwater in Virginia. So for that same example, if you had 100 milligrams per liter and you ran it through your BMP and you reduced it to 50 milligrams per liter, but you also decreased your volume by half, then, and this is just a stylized example, you would get 75% in reduction credit towards meeting the design criteria for water quality. So this is really a way to promote sustainable stormwater management, but there are a number of different ways and flexibility to meet that with the different BMPs that are available on the clearinghouse. The energy balance method, the new water quantity method. Here in red is what, if you had a development and you had no stormwater management for post-development controls in place, you'd see the peak runoff here goes way up. Your discharge, you get that big peak runoff, and the physics are the same, no matter where you are. The longer and stronger the force acts, the more sediment is moved, and so you're going to see a lot of issues with your streams when you have no post-development stormwater management, scour, et cetera. But if you had the previous approach, the simple method, you would have this yellow line, the post-development conventional stormwater management, which does a much better job of meeting that dotted line, which was the natural condition or the pre-development condition. But the issue with that is you're bringing down your peak, which is what you were trying to control, your peak discharge, but you have it over a more extended period of time. So you're still not necessarily eliminating the scour issues and the problems with the stream. So with the energy balance method, we're not necessarily approaching the pre-development hydrologic cycle, but we're doing much better with lowering the the peak discharge rate and extending it over time, as seen in the green line on the graph. So some of these new stormwater BMPs that Virginia has, stormwater clearinghouse, are the same BMPs that you're seeing really across the country, especially here on the East Coast, and also, really around the world. I know that Europe has a lot of these in place, and they've even been much more proactive in some of these. But one example is rooftop disconnection. So actually, if you build a new rest area, you actually, the rooftop wouldn't drain through gutters directly to your storm sewer system. Instead, it would actually go to a rain garden or some other green practice that would treat it. Rainwater harvesting, actually capturing that water and using it for irrigation or for other purposes. Grass swales, which infiltrate the water and treat it, and also return it to the groundwater. That's just an example of an infiltration practice. Bioretention works along those same lines. It's wet swales, wet ponds, and what was previously extended detention. Those are just some examples of non-proprietary BMPs that are available for use in Virginia, but there are also some proprietary or private manufacturer BMPs that are also approved for use in Virginia. So where are we going with stormwater evolving discussions? I already mentioned that VDOT is going to be getting a new permit later this year, likely an individual permit, which will have some different requirements likely that will be more tailored to the DOT system. But there's also TMDLs, or new lists of TMDLs that are coming out each year as approved by Virginia that VDOT will need to add to the list of TMDLs that they're addressing with their stormwater program. Sea level rise and climate change. I think that speakers after me are from Hampton Roads, Virginia, where this is a really ground zero here in Virginia for that discussion, and I'll leave that to them. But that also affects groundwater recharge. Long-term BMP maintenance is a really big issue, especially for DOTs and the maintenance divisions, and really figuring out some of these new BMPs are really very new, and determining the best way to maintain them, and actually maybe which ones should we be promoting in the future because of the long-term life cycle cost when you factor in O&M. Those discussions are still underway, and there's a long way to go in terms of really evaluating which BMPs are really the best for DOTs to meet the objectives of water quality and water quantity control, but also to meet the objectives of lowering the life cycle cost. And then what other cost reductions are there? In Virginia, water quality trading is legal. There's a program for specifically to meet the new stormwater regulations that allows for nutrient trading, and VDOT is actually a really big buyer in that program right now, probably the largest buyer in the state. And then future innovative BMPs, finding ways to incentivize new BMPs that will lower the cost, but also potentially or hopefully raise the rate of nutrient removal from some of these sites. So I'm going to conclude there. I don't know if there are any questions. Yes?
BMP, is that best management practice?
Sorry, yeah, I did say that quickly at the beginning. There are a lot of acronyms in stormwater, so yes, BMP is best management practice. And a lot of the ones that I talked about here, except for the pollution prevention, good housekeeping ones, are really their infrastructure in the ground BMPs. Oh, could you turn your microphone on?
Two questions. One is about the VDOT permit you mentioned. They're currently a small general permit. That sounds contraindicated for a gigantic agency. You said they're moving to a different kind of permit.
They're going to move to an individual permit. It's still going to be small because relative, and I can go back to that graph, relative to the rest of the state, it was at the beginning, it's actually a pretty small landmass of what VDOT actually owns and operates within those urbanized areas, because remember, it's just what they own and operate. So I think, you know, I don't have the table with me, but there's a table that VDOT has that shows exactly in each of the urbanized areas what percentage is owned by VDOT. It's usually like 3 to 5% of that overall land is owned by VDOT.
But it's 100% impervious area.
Not necessarily, no. I mean, the roadway is, but the shoulder and some of the other facilities and land that VDOT owns is not.
Okay. And the second question was snow. And when snow is cleared and all the contaminants that are in the cleared snow, do these BMPs cover that? And how?
That's a good question. I mean, there isn't really a good BMP for salt. That's a question that's plaguing particularly more in the northern section of the United States. So there are a lot of research going into that, and it's a big issue because there really is an effective BMP to remove chlorides.
Since you mentioned salt, on the radio this week I heard talk of beet juice being used experimentally in place of salt for de-icing. And I just wondered if you had heard anything about that at all.
I actually heard something about that too, and there are a number of other salts that aren't chloride salts that are being tested and even used by some DOTs, but they're often more expensive. And you know, some of them might even, the classic problem with fixing one thing with the environment, sometimes you create another problem that you hadn't thought of. Some of them actually are contributing to excess phosphorus loadings to downstream water bodies. So there's still a lot of research that needs to be done on those, and that is being undertaken. They're also, you know, I know New Hampshire, I was talking about this earlier, they have vehicles that can actually sense the road temperature and determine whether or not they actually need to put down salt that they're using there to try to limit the amount of salt that they put down on the roads. Okay, if there are other questions, we'll hold those for after our last presentation. Let's thank Ginny. And so one thing that we haven't spent a lot of time talking about just yet is the need for collaboration on measuring, but also really producing outcomes around sustainable transportation. And so we have a great example of a collaborative effort in our last two presenters. So our first presenter, so they'll be doing this together, but I'll introduce both of them now. Our first presenter is Ben McFarland, who is a senior regional planner for the Hampton Roads Planning District Commission, which is located in Chesapeake, Virginia. The Hampton Roads PDC is a regional planning organization for southeastern Virginia, and there, Mr. McFarland has worked primarily on the Commission's coastal zone management efforts, including studies on climate change, sea level rise, green infrastructure, and local land use policies. He received a BA in economics and a master's of urban and environmental planning from UVA, and he is a member of the American Planning Association and the American Institute for Certified Planners. Our second speaker in this pair is Sam Belfield, who is a senior transportation engineer with the Hampton Roads Transportation Planning Organization, where he has worked for 16 years. He has a BS degree in civil engineering from the University of Virginia and also holds a master's degree in transportation engineering from the University of Texas at Austin. His areas of work include congestion management, freight planning, corridor studies, safety, ITS and operations, military transportation, travel management strategies, and incident management. His wife is also a senior transportation engineer with Parsons Brinkerhoff in Virginia Beach, and they have 3 children ages 14, 11, and 7. So we'll turn it over to them for our last presentation of the day.
Well, thank you, and good afternoon. So yes, my name is Ben McFarland. I'm a planner I'm planner 1, not an engineer, and I'm with a planning agency, not a transportation agency. So please bear with me on that. Every time I get to come and talk to a transportation audience, it's always an adventure for me. And Sam here is from the TPO. So the other instance of collaboration here is that we're both Wahoos. We're both UVA grads. So here we are at the Virginia Tech Center, and happy to be here and collaborate with our academic rivals and partners from the other big state university in the Commonwealth. So today I'm going to be talking about, or we're actually going to be talking about how we're in Hampton Roads planning for sea level rise and other climate change impacts on our infrastructure systems with a focus on transportation. I'm going to give a background on all the work that we've been doing regionally in regards to sea level rise and climate change, and then Sam is going to jump in and focus more specifically on what we've been doing with transportation infrastructure, and then we'll kind of take it back to the more general perspective and talk about where we're going. The other thing I'll just say up front is that we actually haven't really figured out what to do about this yet, so we're here to engage in discussion with other folks as much as we are to present on our work. We are looking for solutions, and we haven't found them yet. So if you have ideas, please feel free to share them with us. So just a little bit of introduction on where we're coming from. For those of you who aren't aware of the other urbanized area in the Commonwealth, Hampton Roads, we're the southeastern Virginia area. We have 10 independent cities. At least we're all from Virginia, so we know what an independent city is. You'd be surprised at how many people don't know what that is or are confused by that concept. And 6 counties. We also have actually 1 town who just officially joined last July 1st, town of Smithfield joined our commission. And we have about 1.7 million people. And we are a strategic location for international trade, military facilities and tourism, major contributor to the Commonwealth. And I'm going to there we go. I got to look over this to see this. And we have, like I said before, we have 2 planning agencies. We have the Planning District Commission, which is, as most of you probably know, a state-enabled, locally created planning agency. And then the MPO, or the TPO in Hampton Roads, and also I think in Richmond, they call themselves a TPO now, which is a federally mandated planning agency. So different jurisdictions, different areas of concern, but we are in the same building, so occasionally we talk to each other. And just a little bit of background on our work in the region and why we care so much about the federal facilities and the military facilities there. As you can see from this map here, there's a lot of federal land in Hampton Roads. The blue areas are military facilities. We have quite a few of those, including the largest naval base in the world in Norfolk Naval Station. We also have a number of other federal agencies represented. The Park Service is a big one. Other Natural Resources Agency, NASA Langley is there as well, right on the water, great location if you're talking about sea level rise. So we care quite a bit about the military. They add to our transportation challenges in the region, as you're probably aware of up here as well, with the commute challenges, but also just as additions to our regional economy, as large landowners and stakeholders, infrastructure owners on the coast in our vulnerable areas, that these facilities are a major concern for both our localities and our residents. So what we've been doing on the Planning District Commission side is since 2008, we've been working with the Virginia Coastal Zone Management Program, which is funded by NOAA to do a whole suite of activities in the coastal zone. And for those of you in Virginia that don't know about the coastal zone, if you know about the Chesapeake Bay Preservation Act, or Tidewater as it is in the legislative context, that's the state's coastal zone. And since 2008, we've received some funding just about every year to promote regional efforts to plan for and adapt to climate change impacts. And these are just some of the reports that we put out for those, and I have a couple of the latest two here with me if you'd like to look at those after we're done. But we also partner with a number of other agencies and entities in the region. We work pretty extensively with Old Dominion University on a number of efforts, and we also have worked with other federal agencies in addition to the TPO. We work directly with FHWA on a couple issues. Big deal for us, a lot of work that's gone into it, and it's now starting to bear fruit in that this work is starting to be incorporated into local plans and also regional planning efforts with the TPO. So why do we care about flooding in Hampton Roads? Well, these pictures are a pretty good illustration of that. Those ones on the left there are from the city of Norfolk before the construction of a major seawall in the city and surge gate that was put in to protect the downtown area. But even with the construction of major infrastructure projects, we still have with recurrent flooding. And you can see on the right, those are also areas in the city that are even now facing the specter of recurrent flooding on a really pretty normal basis. We have some areas that really only see flooding during storm events, but other areas where you'll see ponding or stormwater systems back up into roadways or into backyards pretty regularly, whether it's once a month or even more frequent than that depending on the area. So it's a major challenge for our communities, for our residents. And so when we talk about what we try to do about sea level rise, we have a few questions. This is the planner coming out of me. I want to know the why before we actually get down to the objective stuff of what to actually do about it and crunching the numbers. But really, when talking from a planning perspective, we need to know a few things. First of all, when we're talking about sea level rise, how much will sea level rise and how quickly is it going to rise? It's a major question that has kind of been answered so far, but there's still uncertainty there. What are the causes of sea level rise, and is there anything that we can do about those causes? And then also, just I guess as an extension of that first question, which areas are actually vulnerable to sea level rise and flooding, or will become so over time? So a little bit of background on sea level rise for those of you who don't get to dive into this, no pun intended, every day like I do. We have kind of two, when we talk about sea level rise, we talk about both global sea level rise and relative or local sea level rise. And global sea level rise, that's the climate change, global warming affected sea level rise. And it mainly occurs as a result of ice melt from glaciers, but also the thermal expansion of the oceans. And up till now, the thermal expansion component has actually been the largest contributor to sea level rise globally. But when we go to local sea level rise, which is really what we care about, because that's what is going to tell us what places are going to be underwater, what infrastructure systems are going to be affected, we have to include a few other components as well. And one of those is ground subsidence. And in Hampton Roads, we're sinking. I think they might also be sinking up here a little bit too, but we're sinking faster down in Hampton Roads. And the two causes of that are first, glacial isostasy. So if you go back to the last ice age where you had these huge glaciers all over the northeast United States, their glaciers are really heavy, and they push down on the land. And the areas that are to the south of those glaciers in the northern hemisphere are kind of bumped up a little bit, kind of like a seesaw. And as those glaciers melt and retreat, the land that was previously being pushed down rises back up, and then the land that was being pushed up artificially starts to sink back down again. So we're on the sinking component. Actually, most of the United States in the northern part of it is also sinking a little bit due to that. And the other, probably the more significant component for us is groundwater withdrawals. And we have a number of major aquifers that are contributing quite a bit to the drinking water supply, to industrial users. And in an aggregate, those all contribute to about 2 millimeters of subsidence per year across our region. Just that's the average. It obviously varies from bit to bit, depending on if you are really close to an industrial user, further away. But there is regional subsidence effects throughout our entire jurisdiction. The other I'll bring up now that's becoming more of a concern is as the oceans warm up, ocean currents are starting to change, and so there are dynamic things going on in the ocean. And one of those is that the Gulf Stream is actually slowing down. And as a result, water that was being kept offshore is now starting to slosh up against the mid-Atlantic. And so you may have heard of the mid-Atlantic from roughly South Carolina all the way up to Boston being referred to as a hot spot for sea level rise, and that's why. So take away from that, we have sea level rise from global causes. We have sea level rise from more local or regional causes. And together we're experiencing roughly, and I'll show a chart here in a second, but it says here about 1.5 feet per century is the long-term trend. And I think so far since they started measuring the tide record at the Sewell's Point gauge in Norfolk, that was in 1927, we've seen a 1.2 to 1.3 feet of sea level rise. And so just some of the impacts there, the general impacts, and then these get tied to transportation, obviously, but one is some areas are going to be underwater at all times. Some areas will be subject to flooding on a regularly occurring and more frequent basis. And other areas that to date have not actually seen any flooding or very rarely have seen flooding will start to see it more and more often. So this is just an example of some of the data that's out there on sea level rise. This is from the Sewell's Point gauge in Norfolk at the Naval Station. It's taken from a NOAA tide or water level station. It shows mean sea level for the monthly mean sea level. So they average it over the course of a month and remove annual or other seasonal cycles that are in there and plot it against the time you can see there on the bottom. And so it just shows a pretty continuous upward trend. There's a little bit of up and down from year to year and month to month, but overall the trend is upward, and that's replicated at each of the tide gauges. Not the same number, but certainly the same trend is replicated at all the tide gauges we see in Hampton Roads and all the ones in Virginia, actually. So, and this is, we talk about projecting sea level rise out to the future. So we look at some of the climates that have been produced for the National Climate Assessment, and these are what those 4 scenarios are. The global scenarios are 0.2, 0.5, 1.5, or 1.2, excuse me, and 2 meters of sea level rise globally. And for Hampton Roads, that really translates to between 1.6 and 7.5 feet of sea level rise. And at mean high or high water, this is what that looks like. So those dark blue areas are the ones that we're fairly confident will be underwater at least daily. The light blue, fairly regularly flooded, and then so on and so forth. So at the highest scenario, sea level rise, which is the catastrophic, we don't think this is going to happen, but if everything melts, this is how quickly it can melt scenario, those yellow areas will be underwater every day, or roughly every day. So it's a big deal for us, and trying to figure out what to do about that and how to plan for it, and specifically how to incorporate sea level rise into our infrastructure planning is a major challenge for us. And so to date, we've been working with a number of our partners, different federal agencies, like I said, at the state, the federal level, but also academic partners, UVA a lot, also ODU, some of the others as well. We've done some work with USGS on some of these issues, and so trying to figure out what to do with it. And one of the applications of all this work that we've done so far has been with Sam and his work with the TPO on how to combine our interest in sea level rise and impacts from sea level rise on our interest in planning, transportation planning for military users. And I'm going to go ahead and turn it over to Sam, and he'll take us part of the rest of the way.
Sure, thanks, Ben. Today I'd like to just talk about briefly that we worked on together a couple of years ago where we looked specifically at sea level rise and storm surge impacts to the roadways that serve our military in the region, as they are very important to our users in that area. We also like to talk about how we plan to take this methodology that we've done in this past project and apply it to all the roadways within our network, and that's something that we plan to do over the next year. So just before I begin, I want to provide a little bit of background about the Military Transportation Needs Study. This was something that began about 5 years ago, and it was the result of several military representatives that spoke to our MPO board, and they were very concerned about transportation in our region. Specifically, they were concerned about traffic congestion and the deficiencies along that network. So it occurred to us that we would address those needs by coming up with this new initiative as a part of our work program called the Military Transportation Needs Study. As phase 1 of this study, we broke it into 3 phases. We identified a network of roadways that would, quote unquote, serve our military. We began with what's called the Strategic Highway Network. If you're not familiar with that, that is the minimum highway defense network that's established by the Department of Defense that deems the most critical roadways that are important for military cargo and travel in the event of a defense emergency or deployment. Within our region, we have many more military facilities in our region, so we expanded that network that's shown in blue to include other roadways that serve other supporting sites for the military throughout our region, and those are shown on this map as red. Now, as a part of this study, it was a 3-year effort. It consisted of 3 phases. In phase 1, we determined what this network looked like, and then we also we looked at the deficient locations along that network, specifically at where congested roadways were, where our deficient bridges were, as well as inadequate geometrics. Phase 2 was to do a comprehensive military survey to find out exactly what their transportation needs were. Phase 3, which you would be interested in, we expanded phase 1 of this effort to look specifically at this roadway network as it relates to the impacts of sea level rise and storm surge to this network. So at the TPO, at the MPO level, we typically plan on a 20-year planning horizon. So it occurred to us that we would try to come up with a scenario that would look within that planning time frame. So to do that, we came up with 2 scenarios. Number 1 was a 1.5-foot sea level rise scenario, something that would be the result of sea level rise that's reasonable enough to expect to occur within that time frame. And also, if a hurricane or a storm were to pass within that 20-year horizon, we added on an additional 3-foot storm surge to come up with a 4.5-foot rise scenario. So those were the 2 scenarios that we primarily looked at when we did this study. This particular map, it combines the work that Ben had done at the HRPDC, taking his inundation maps for these 2 scenarios that he ran specifically for this study. And they are shown here on this particular map. You can see the areas that are expected to be submerged in purple are shown in the map by the 1.5-foot rise scenario, and the areas that are shown in green are the additional areas that are expected to be submerged on the 4.5-foot scenario. So what I did is I took my roadway network that serves as military, and I overlaid that using GIS on top of Ben's maps. And the conflicts that existed, we were able to identify these roadways that would be potentially submerged under that scenario. So this is the map that you're looking at here is the results of the Hampton Roads Peninsula, which is the northern side of our region. The south side is shown here on this particular map. One of the things that we looked at, in addition to just not only identifying the roadways that would be potentially submerged under these scenarios, were the ramps that would be potentially submerged, and those are indicated on these maps by are shown in orange. This is something that a lot of places they may think of identifying the roadways that would be potentially submerged, but they're not thinking about what if my travelers can't access the roadway if they can't get to it if the ramps are submerged. So that's something that we thought was important to identify for our military. Another part of this initiative, we looked specifically at which military gates would be potentially blocked. This is important information to our military as they can plan the use of other military gates if this scenario were to occur, and they can also use this information to make further improvements on their for access to and from their facilities if they know that these potential gates will be submerged under these scenarios. Now, as a part of this study, we included a number of recommendations. Number 1 was to encourage these military sites to work with VDOT, the cities and the counties, to develop detour plans for these potentially submerged roadways. To also consider the potential climate change impacts to roadway design for new projects in the region. And also to conduct further studies to determine the impact on drainage systems. Most importantly, the recommendation that we came up with was to get our MPO board members on board with this issue of climate change and the impacts that are forthcoming and how they affect their decision making on transportation projects. This is something that they all know that it's important, but they have not incorporated this into the planning process to this point. So later this year, as I mentioned, we plan on conducting a similar vulnerability analysis, not only on roadways that are important to our military, but to all roadways within our region. And this is a map that shows the roadways that consist of our congestion management process. It's a much more comprehensive roadway network. It's made up of all of the primary roadways, interstates, as well as some local roads that serve our communities. And so how do we go about tying this information into the planning process? The way that we envision doing this is through what's called our project prioritization tool. This is a tool that we use within our planning agency to score candidate transportation projects in our region based on 3 primary criteria: project utility, economic vitality, and project viability. The beauty of this tool is that we can make changes to the tool on the fly. We talked about earlier about making version 1.0, 2.0. We are actually in our second version of this tool. So we're constantly, as we are doing a number of studies in our region, refining this with new data that becomes available. And one way that we envision refining this particular tool is to incorporate now the impacts of sea level rise and storm surge. For example, points within this tool could be awarded to projects that either improve these potentially flooded routes, or they provide alternatives to these roadways as a result of building these new projects over the next 20 years. As Ben mentioned, this is something that's completely new to us. We have flexibility within the tool as to how many points that we award to these potentially flooded locations. However, it's exciting because this is something that hasn't been thought of, and the more and more that we speak about this issue, we're learning that many regions aren't incorporating this at all, and they don't know how to incorporate it. So this is a good practical way that you incorporate the impacts or the potential impacts of flooding into your planning process. So with that, I will turn it back over to Ben. He's going to talk a little bit about some next steps for our effort, as well as some potential research opportunities.
Thank you, Sam. So, moving forward, this is obviously something that's not really going to go away anytime soon. So it's something that we're going to continue to work on at both the PDC level and also with the TPO on how do we take these projections on sea level rise and incorporate those into planning decisions at the regional level, but also at the local level. And one of the first things that we're working on right now is an update to all of our regional sea level rise inundation maps and our scenarios. So before, you saw the map that we had that showed the 4 global scenarios from the National Climate Assessment. And in our discussions with localities, they didn't find those scenarios to be particularly useful as a decision-making tool. And so this new step going forward, we're going to be looking at, for example, 1-foot increments of sea level rise, and they felt that would be something that they could more readily use in their planning decision-making processes. The other thing we're going to be changing about those maps is we're going to be using probabilistic storm scenarios combined with sea level rise. Very rough bathtub model of how sea level rise could affect storms, but probably better than nothing. I'm not 100% certain that it's better than nothing, but pretty sure. But the big impetus for why we're doing this is that last summer or last fall we got acquired new elevation data, new LIDAR data for the eastern half of the region, and a lot of that area hadn't been covered for the last 10 years. And for those of you that aren't versed in LIDAR data or elevation data, light detection and ranging, it's the technology has just leapt forward in terms of its accuracy, its resolution, and so the stuff that we had that we were using before is much worse than the stuff that we have access to now. And so it really made a big difference in terms of the quality and the accuracy and the fidelity that we have for those new maps. And that means that it'll be much more useful to not only the TPO, but also to our local governments. The other thing that we're working on right now is we are still coordinating with our partners. We have recently set up in the last year a special committee on recurrent flooding and sea level rise for the Planning District Commission. The entire TPO, I didn't really get into this at the beginning, but the TPO jurisdiction is entirely within the Planning District Commission jurisdiction. The PDC just has a couple extra members that aren't in the TPO, and that's just a jurisdictional political decision. I'm not sure exactly why that happened the way it was, but it is. But what that means is that the people that are coming to our Planning District Commission meetings also happen to be a number of the people that are involved on the transportation side from the local level. So we're usually talking to the same people, or at least people in the same departments, and so what one group discusses filters back to the localities and goes to another way. So although this is a PDC committee that we have set up, it is coordinating with federal agencies, with academic partners. Sam comes to those meetings and participates, and so we're looking forward to using that as a way to try to identify consistent policies that we can hopefully help the localities implement across the region in terms of design standards or sea level rise scenarios that are appropriate for planning documents and other decisions. So that's something that we're looking forward to doing. As Sam said, looking at how to incorporate sea level rise or flooding into the transportation planning process. I believe in the current iteration of the prioritization process, there is a opportunity to fill in some points for evacuation routes, which is something that obviously is related to sea level rise and flooding, but not the whole story. And so looking at how to expand that component is going to be something that we're looking into. And then also just in general, not just on the TPO side, but for all of our regional plans or our local plans, how do we incorporate sea level rise? It's not just as simple as putting a map in. How do you take that information and turn it into policies or recommendations or actionable information that a locality can use to make decisions on its own? And so, we, as Sam said, we're looking to partner with other groups. We're already working. I think John Goodall probably is on the line right now from UVA and his cohort at how do we update design standards, for example, to account for changing precipitation in addition to sea level rise. That has a big impact on transportation infrastructure, but it also has an effect on our stormwater management infrastructure as well. And that's the other key infrastructure group that we have that meets with the PDC is our stormwater managers. As Ginny mentioned before, the MS4 permits, all that stormwater side of things that relates to transportation, but the design standards, the numbers being used for the sea level rise scenarios or the IDF curves should ideally be the same for both transportation and for stormwater. Also looking at, what information can we take from other places, whether they are in the United States and Virginia, if we can find them, other states, but also globally in terms of best policies. And then looking at, expanding on the analysis we've done, not just looking at specific, networks or road networks, but really like getting into things as nitty-gritty as bus stations or light rail facilities, railroads, yards, maintenance yards, all sorts of facilities. How do we update, how do we do the assessment that's not only, what's vulnerable right now, but how do we inform decisions about where to put things in the future? And so that's just, an inkling of how much we're looking at incorporating this sort of information into our plans and processes. But that's just kind of a summary, and we'll be happy to answer any questions you might have. Thanks again for sticking with us all the afternoon. And for those of you that stuck around, really, really appreciate it. Thank you.
So we'll start by taking a few questions related to this Blue Highways segment, and then we'll open it up for a larger discussion. So if there's any questions that Emily has or from our audience.
First off, wahoo George Foster. I'm curious if in any of your studies and the maps that you found, I noticed that you noticed a lot of areas that would be potentially underwater in the roadway system. And in many ways, transportation planning is a very reactionary field. Did you identify any areas or any facilities that you're like, no, we are not going to literally sink money into this because we see this entire neighborhood or this entire facility not being something that we can fully use in 40, 60 years or so? Kind of very, very long term.
No.
No.
and I'll just take this hit for Sam here. Haven't gotten to that point in our discussions where we're actually talking about specific areas where we would definitely want to retreat from. There have been some discussions, I believe, in other areas of the Commonwealth. I've heard of stories on the Middle Peninsula, for example, where VDOT is looking into abandoning rights-of-way or roadways to giving them back to the locality and saying this is your problem. But those are all anecdotal. It's anecdotal information. So, but no, we haven't. And as Sam said, we really haven't incorporated the sea level rise information into the project planning tool. There have been examples of specific projects that have been done to mitigate flooding impacts. So that side of things is being done. But as far as abandoning areas or deprioritizing areas, that hasn't been yet.
Just, so I have a comment from the Ginny's part. Let me make sure where Ginny is. Oh, okay. Okay. So just somebody's reporting that we have a big problem lately with salt and impacting our street trees here in Leesburg, also damage to concrete. So.
Where, I'm sorry?
In Leesburg, Virginia?
In Leesburg, Virginia. Yeah, I mean, unfortunately, it's that catch-22 of preparing the roads for safety versus protecting for streams for water quality, and the research isn't there yet to determine the best ways to treat chloride. There are a number of localities where and contractors that VDOT uses that use salt, but there are other ones that use sand. It depends on where you are in the state and what is being used. So it varies widely, but there are known problems with most of the different types of applications that you can put down on roadways to deal with icing problems. But that's that question of safety and economics that we've sort of been talking about all afternoon.
Right.
And there's no real easy answer.
Right. That makes sense. Also, I've been busy as we're sitting here, so if you go to massutc.org and the top news post does have all of today's presentations. Another way to get there is tinyurl.com/May6downloads. So that may work. And so the webinar people have that, and we'll try to email everybody with that. But those are the only questions I think I've received so far, or comments.
A question, but first I want to start with a shameless plug, and I'll admit that because what I'm doing is something that nobody else is doing, so I really don't fit in anywhere. It's called Cargo Fish Physical Internet. You can find it online. My question is, are you familiar with the 10-inch vacuum tube system at the Colorado International Airport that was built about 10 years ago that handles about 80% of small parts, 80% of parts and tools movements for aircraft maintenance there at that airport? Are you familiar with PEVCO, Pneumatic Tube Systems in White Marsh, Maryland, which has most of the government contracts for pneumatic tube systems, such as at the Pentagon? I know for the most part they've fallen by the wayside because digital information systems are handling information flows that used to be physical. But with all of the military, installations right in the Hampton Roads area, your area in particular, there are probably a lot of courier services running back and forth between those bases for something physical that could not be reduced to information. And no matter how small it is, if it's an immediate need, they're dispatching a driver at a minimum in a 4,000-pound car to suffer congestion, burn the energy, take the time. And I have a solution. And I have no trumpet. And that's what I'm doing here. So apologize again for the plug. That's Cargo Fish Physical Internet. And they're happy to show you more about it. I happen to have a little prototype here.
And that's actually a great point to transition into our sort of wrap-up discussion, reflecting back on the entire day. What are sort of the new emerging research areas or needs that we've identified, or what are some areas of research that need to be transferred into practice? And so I'm going to come to the front and facilitate a little bit. Can we first go around the room? So for those who are still here, we'll start in the back corner here. If you could just introduce yourself that those in the webinar know who's here and so that we all know who we're talking to, and then we'll have some discussion.
My name is Olcay Sahin. I come from Norfolk, Hampton, they just introduced. And I'm PhD student at Old Dominion University in Modeling and Simulation Department. That's all.
Make sure you talk into the mic.
Edward Mayama, Parsons Brinkerhoff.
My name is Robin Hamer. I'm program manager for TTA, which is the Virginia's LTAP program.
I'm Beth O'Donnell. I'm the Director of Finance for the Center of Transportation Studies at UVA. Work with Emily Parkini on Matt's UTC.
I'm Robert DiDomenico. I'm the inventor, developer, and sole proprietor of Cargo Fish Physical Internet, the world's next utility.
Ginny, Snead, Lewis, Berger.
George Foster, recent graduate of UVA Urban and Environmental Planning program, so looking to make some friends here.
Gary McVoy, independent consultant. I was introduced earlier. Thank you.
Gerardo Flinch with Virginia Tech.
Yeah, I'm Emily Parkini with University of Virginia.
My name is David Patton. I'm a transportation planner here in Arlington County.
Georgine Gary, independent consultant.
All right, so thank you everyone for staying with us. So Joe Zietzen started us off actually at the very beginning, if you remember back to 10:30 this morning, and he listed some areas of potential research needs. So he mentioned freight, social dimension, climate change, alternative energy, transportation and health, autonomous and connected vehicles, and decision making. So we've heard about several of those topics, not all of them. So what we'd like to do right now is just sort of crowdsource what are some areas for future research, perhaps that the UTC could tackle in the future, or different TRB committees. Also can open up for just general discussion. And I'll try to keep track of some of these ideas and we'll capture that for everyone afterwards.
Well, the area of freight and autonomous vehicles, typically when I mention it, I'll hear people talk about drones because Amazon is a big name. And that's almost unfortunate because aviation uses a lot, it's a very high specific energy, and the idea of using drones to deliver everyday things, it would be far more expensive than any form of ground transportation. And so it definitely would never become a big handler of much, but that's where all the research is on aviation drones. It must be the exoticness of it. But there's no research basically for a track drone system, a capillary sort of railroad, other than what I've been conducting for 5 years.
Well, we've had several questions about chlorides and use during winter storms. So there aren't any chloride TMDLs here in Virginia, but that doesn't mean they won't be here in the future in research into alternatives or other technologies other than what's being used right now.
Something that hasn't been explicitly addressed much during the day, although it came up sort of peripherally, is moving from statewide and federal policies down to local levels and urban landforms, the urban grid. Granted, the talks today were about highways, but we deal with streets a lot here in Arlington. There's a very sensitivity to scale, urban forms, those sorts of things.
you have related thoughts, feel free to add those to the discussion. We don't have to necessarily jump from topic to topic. Relate some thoughts.
As far as research needs with regard to sustainability, given that at some level most things come down to money as part of the decision process, I think more work on how to establish values for various outcomes and impacts would be very useful. And examples of how to apply this. I mean, I looked at the Hampton roads analysis, and it's excellent, but it all goes back to weightings. And if you could use dollar values instead of those weightings, I think it would be it might be a more elegant solution.
I'm going to jump back in at that point. We've just come through our local budget cycle with our local government here in Arlington County. New budget year starts July 1, and I wish I had had your frame analysis when we went through that. We had a sketchy couple of months where our program, which is about as sustainable as it could be, it's about sidewalks and bicycle facilities, we were on the chopping block, and we survived. And through some sort of horse trading that happened behind the scenes, I don't know really how it happened, but if it could have been public, if it could have been on a commonly shared basis that everybody understood the values and factors or lack of weighting factors, it would have been really helped us progress through that sequence.
Could have improved the conversation, if not that.
Correct. And what do you call that framework you have with the 5 different stages?
The sustainability maturity model.
That was great. That's one of the highlights for me today, is to see that in a single chart. We're somewhere, depending on what you're measuring, my local agency is somewhere on one or another of those stacks. But boy, I'd like to see us make a little more concerted effort to move along that continuum.
Speaking in terms of valuation, a year ago I heard it at a conference in Quebec that the first dollar spent on moving product from factory to point of consumption gets you from the factory to the distribution center, a couple of thousand miles, whatever it is. The next dollar gets you from the distribution center by truck to the loading dock at the Walmart, if you will, a few hundred miles by truck. The next dollar gets it from the loading dock to the shelf. And then actually the most expensive part is the consumer driving it, picking it off the shelf and driving it home. And I did a similar analysis on energy. For every 100 pounds of goods that we import from China, the first gallon of fuel takes those goods from a couple of thousand miles to the coast, puts them on a ship, 6,000 or 7,000 miles across the ocean, puts them on a train, brings them to a distribution center near the East Coast. That's the first gallon per 100 pounds. From the store to the home, each 100 pounds of goods takes a gallon a mile. 4 orders of magnitude difference, roughly. But there's a focus on improving the efficiency of freight and a lot of rejection. MIT rejected any consideration for this because they said everybody knows all the ton miles are happening upstream of the store. But they ignore the fact that 80% of the energy is being burned downstream of the store. Only 20% of the energy is burned upstream of the store because we already have great efficiencies when we aggregate freight.
Well, I'll take that in a slightly different direction. One of the areas that we haven't talked a whole lot about is that social dimension. That was brought up at the very beginning, but we're kind of touching on it. There's aspects of choice, public process, public input. Does anyone else have other perspectives or questions that you could frame around that social dimension?
Well, in the social dimension, if a system is simply usable like a utility, then when we get old and it becomes less convenient, more difficult, and eventually impossible to do our own shopping, we don't always have to visit the store, and we could maintain our independence much like we do with energy. When we need it, we flip a switch, or when we want water, we lift the tap. But without any system, we're at the mercy always of having a delivery person or making a trip. And so from a social aspect, exploring the potential of a system, now that we have the technologies to implement it, could make sense, but nobody's looking into it.
I think another aspect of the social dimension is, at least one of them is the value of a transportation service. For example, what's a bus ride worth that takes somebody that doesn't have a car to a job that they couldn't get to otherwise, versus the value of a trip on the same bus by someone who could drive otherwise? Or what is the value of accessibility for the aged or the very young to service, education services, et cetera, versus the public at large? Do we need to break these down a little bit in order to capture the social dimension of our services?
I'd like to add that we're a society of people that, we have this attitude that we got to have it right now. And so it speaks to what the gentleman in the back was talking to as to making, a number of different discretionary trips. You have this craving for ice cream, so you just go to the store just to go grab some ice cream. Or, how do we incentivize people to combine these trips so that we aren't taxing our infrastructure beyond what's necessary?
We could look deeper, though, at developing value, the most value from the least resources. When Malcolm McLean containerized ocean freight in 1956 with the maiden voyage of the Ideal X, the handling cost for that shipment from Elizabeth, New Jersey to Houston, Texas was a 95% reduction. In the subsequent 6 decades, the handling overhead of global trade has plummeted and made international trade possible. Without any system, we have our retail distribution, which is fraught with overhead and handling. And once we look to actually a true automation of distribution, we could have a raised standard of living because we could deliver that distribution with far less overhead. Now, some would be Luddite and say, well, then we won't have anything to do. But that argument could be made about anything. And I don't know any bit of progress in the world that succeeded because it was harder than what it replaced. Typically, it succeeds because it's easier. It delivers more value for less work, and it raises the standard of living on average. The thoughts that drive me. Sorry.
In the social theme, how do we establish values for things like context-sensitive solutions, which we know are reflected in property values, and relate that to livability, quality of life, so that these social concerns can be placed on an equal footing with life cycle costs and other things that are easier to measure?
Yeah, maybe in line with that, different stakeholders will value it different, so the perspective from the different folks involved in this process may be important too.
I'd like to jump in on the comment about values that we had, and I think, when we're talking about our focus on sea level rise and flooding, and how do we incorporate that into our objective planning processes for infrastructure projects. The value question is, how much do people want to keep living where they're living, and how do you try to incorporate that hazy, subjective assessment into what is ostensibly supposed to be a numbers game, and still, or is the question, do we just, recognize that it is subjective and it's political, and we try to separate the two out so that we have a best objective case of the value or the benefit of a given project, but also fairly incorporate the subjective component of people's wants and desires that is really hard to quantify.
Yeah, to chime in here, I think that the valuations at best can inform the political process. At the end of the day, we live in a democracy, and these things are decided, public policy is decided through the democratic process. This is simply a means to inform it. So if it's going to cost society $1 million for somebody to continue to live in their $100,000 home, and society decides that's fine, okay. We had the conversation. We did the analysis.
And so the question then is, if it's not measured, does it matter? So I believe that was something that was asked at the very beginning of the day. So how does this map to, say, MAP 21 performance measures, local performance measures?
If I could give a comment to that, the analogy is kind of like, it's a terrible analogy, but at the dentist, I have a dentist, and he has his laser light, and he says, I hate to use this laser light to look at teeth because I usually don't like what it shows. But we always use the light because we're trying to get something done. So the reluctance to measure something, it really is a kind of a stalking horse for, we really don't want to deal with this. Which is okay, but let's be mindful of it.
One thing that a lot of people opened up was the three-legged stool analogy, or the environmental, economic, and social aspects. And a lot of people really went into depth on both economic and environmental today. And I understand that environmental was a bit of the focus, and economic is very easy to put numbers on. But how do we as transportation planners and experts promote social equity? And I think understanding that while some things like roadways we may think of as blind to who uses them and what background they have, really are not, and why some people will ride buses versus a light rail or something for very, very social stigmaed reasons. I think exploring that with more research and trying to find numbers, especially linking two difficult subjects to put numbers on, both environmental and social.
So Emily, do we have any comments from our webinar attendees?
No, they haven't added anything, but they're definitely welcome to. I think we've definitely been bringing up some interesting things, like Gerardo said, that different stakeholders may have different values. We're talking about the equity issues. I think one of the problems with like assigning a dollar value to everything is that if people disagree with that dollar value, then they'll like sort of disagree with the whole thing. I mean, so it sounds easy to let's make it dollars, and that way it's tangible to everybody. But there's still so much subjectivity to it.
Yeah, and that's why I think we should always be talking in terms of ranges of values.
Okay. Ranges sound good. Yeah.
Otherwise, the thing falls on its own weight. in sort of the crude representation of a range of views.
I'd like to go off in a completely different direction for a second. And
Go for it.
one of the, oh, yes, I should be on. Yes, it's on. One of the things that's come up in some other fields, particularly water resources management, is this concept of stationarity, that, you know, we are doing a lot of planning for future projects based on data from the past, and with climate change and other changing social or economic conditions, that past data may not be indicative of what the future will hold. And I think that there's an opportunity in transportation, you know, to really use the fact that there's a lot of funding for transportation research to look at these kind of interdisciplinary issues of how do you effectively plan for an infrastructure project when you do not know what the climate conditions will be, when you do not know what the socioeconomic conditions will be, in a way that really explicitly recognizes the fact that there is quite a bit of uncertainty in what those future conditions will be like.
I'd like to jump in and say that I think the larger issue is not, you know, Project A versus Project B, like was mentioned earlier. I think it's more about the scorecard of our overall system, of each individual component of our transportation system. How do you show or prove to our political leaders how bad our infrastructure is, how bad we are in need of improvements, and then to get the funding that we need, because if we don't have the funding, you can't build anything.
The term business case comes to mind. You know, if you can construct your arguments on sustainability in a kind of a business case format, I think it's helpful in terms of communicating and refining some of the stuff. We've got all these wonderful tools we use in our economy that we don't really use in our political and social calculations.
There's sometimes a benefit to maybe looking at things from the point of view outside of transportation. I think few people know that 15% of all the ton miles of freight that move in this country move by pipeline. Those are typically raw or finished petroleum products. And although 95 to 97% of surface transport is fueled by oil, the remaining 3 to 5% that's fueled by natural gas, that's not buses and garbage trucks. Those are pumps on petroleum and natural gas pipelines that are directly fueled by natural gas. The other stuff's minuscule. But to get a real grip of the ratio, U.S. municipal water systems and municipal sewer systems carry 6 times as much freight as the remainder of the entire U.S. freight system. We move 1,000 pounds of water to each person and 1,000 pounds of wastewater from each person on average per capita. But daily, the remainder of the U.S. freight system moves about 360 pounds per person in the country. And if there's something that can be gleaned from that as to, you know, roads aren't the only way to move stuff. And the other funny thing is, trucks carry 85% of the freight, some length of the trip. Railroads don't touch as much of the freight, but they carry it longer. In fact, trucks and railroads in North America carry about the same ton miles, but the railroads do it for a fraction of the energy and cost, not as cheap as pipelines, but of trucks. But of course, they're not capillary. They're too capital intensive to go everywhere. They're arterial. So there's some of the things that I dug up over the years. Recognize a little bit of, perhaps they play into what I'm working on. Sorry about that.
Okay, any last comments or thoughts or questions for each other?
Thanks for having me.
Thank you all for being here and on the line. Okay, well, despite the best efforts of technology to slow us down today, we are going to end a little bit early. So thank you again. As Emily pointed out, resources are already being posted on the Mass UTC website. We will also have the webinars posted so you can hear the wonderful voiceovers for all the slides. And we may have video depending on how that turns out. So, which will be a great resource for personal use, but also for educational use. So please take a look at all those resources.
We did have one. How many of the presentations, or perhaps only the contact pages, I didn't take any notes, would be available on the website?
They're all already available.
Great. Thank you.